Hello again. So this question, yeah, I understand the confusion. But before we start with anything, let me talk about one part here, which is the V. When we're talking about the V, you want me to answer like the last part, I know, but I have to go through something before we start that part, okay? Now, the V here, we get the whole voltage, the total one from here. It is the like the power supply for the all of the voltage that is going to be distributed in this circuit, okay? Part of it is going to be here. And let's call this VR since it is on the resistance or resistor. And this one is going to be V lead. Well, obviously because it is on the lead. So we have the total V divided into, which is what happened in a series circuit. The voltage is going to be divided, distributed in the whatever the equipments that there. As long as they have resistance, then they will have a voltage there. So it is VR plus V lead. This is the total. The total we got from the cell or from the power supply, and then it is divided on those two, while the current is the same in all of the circuit. The current in a series circuit, it is the same, it is constant, and not constant, it's just the same for all of the devices on the circuit. But for the voltage is going to be divided. So this is the first thing we have to talk about. And then let's go back to this question. Now, they're saying, okay, let me tell you something else. Here, this part, the table shows the results of the investigation. The investigation has been done on, the diagram shows the circuit used investigation, the relationship between current and voltage for the light emitting diode, which is the lead. It means that this one is only for V of the lead. What did I do? For the lead. So the VR is not given. We don't know it. It's not the VR, it's not the V total. This is only for the voltage of the lead. All of the investigation. Tamam? Until here. So when we go back to this one, we only get this from the student's investigation. Those are like VR and VT are not known for us. The question, the last one, is asking about those two guys. Like my current, any current larger than 50 milliampere will permanently damage the lead. And 50 milliampere, it says like if the power supply gives that amount of current, then we will damage the lead. Tamam? The resistor in the circuit has a resistance of, this is R, so what do we have? We have the maximum I in the whole circuit, and we don't care about that because in the whole circuit it is the same I. This is as long as we are going in a series, not a parallel, not other type of circuits, okay? So it is 15 times 10 to the power 3, right? Minus 3 ampere, since it's a milliampere. And then we have R for the resistor as what? As 370 ohm. Use the results from the investigation to determine the maximum voltage of the power supply. It means they're asking about this here. How much V total, how much we should give the circuit by the power supply in order for us not to damage, like to produce a current that does not damage the lead. And so we have to find this one, the total. From the investigation, we can know, like they gave us one important information, which is that this is the I max, which means that this is the V lead max. This is the V lead max. We want this part. This is very important information. Let's have it here. We know that for V lead max, it is 0.6V. Where did I know that? Because they give us the Imax for the circuit, and so I know this is the right, the maximum voltage of the LED here. I'm sorry if there is some noises because my cats are playing around like here now. But anyway, so here we have the voltage, the maximum voltage on the LED, and they're asking for the voltage for total. So what do we miss? What do we miss at this point? I know it's not working. I wanted to, anyway. What do we miss here? We miss the VR. From where do we get the VR? Which is the voltage, the maximum voltage on the resistor. And of course, we're gonna get it from max. We're gonna get it from the information given to us here, these information here. So we know that V generally is equal to IR. And now here we're looking for the maximum VR, which is the voltage over the resistor. And it is I, the maximum I is going to be the one helping us on knowing what is the maximum voltage, times the resistor resistance of the resistor is constant, which is given to us here. And so you just times those together. Let me find, where is my, let me find it out. So it is going to be 4.05 volts. This is the maximum voltage over the resistor. And we also have the maximum over, like this is 6 here. So going back to this point here, it is 4.05 plus 0.06, which means, let's go back here, write it in the right way. So V total, which is the supply from the supply, is equal to VR on the resistor plus the V LED on the diode or the LED. And here we're working with max. For all of them, we want them to be on their max volume or value. So VR max is equal to, it's 4.05 plus V LED max, which is, we got it from the investigation, so we really needed that part. And when you add them together, you'll end up having 7 volt, I guess. This is the V total, which is the one that we're going to need, like, to be under it, below it, because after, like, anything greater than 4.7 here, if you supply this circuit from this power supply with anything that is greater than 4.5, then you will damage your LED. I hope it's clear. I think the point where you you were confused is that we have three kind of voltages working with. One total, one for the resistor, and one for the LED. And the investigation is only working with the LED one, while the one given the information about in the question was for the resistor. And the total one should be the summation for those two, because this is what happened to the voltage when it is in a circuit, in a series circuit. I hope it's clear.